Hello, everybody. I am Mr. Lakin, and I am just being uh, super weird right now because this is not my prime time for making videos. Currently, it is 9 o'clock p.m., which is, again, usually not the time I make videos. Usually, I make videos at 12 or 1. I might be sniffing throughout this video, and I don't want you to think that I actually have the coronavirus, because to my knowledge, I do not. I believe it is allergies. I was outside a lot today, did not take allergy medicine. The purpose of this video is to do 2007 number 3. This is a calculator okay question, although looking at these problems ahead of time, this does not look like we're going to need the calculator that much. But again, you are welcome to use one for this video, or for this question. Okay. So first thing I'm going to do, actually, before I even begin to problems, is read this nice little paragraph that they give me here. I'm going to highlight some important words here and just indicate what that might mean. So functions f and g, so f and g prime, f and g and f and their derivatives are in the table below. It says they're differentiable. Please keep in mind that anytime you see that word differentiable, continuity is implied. So continuity is implied, and continuity for the original functions. For all real numbers, so that functions f and g are differentiable for all real numbers, then g is strictly increasing. Okay. Well, when we say g is strictly increasing, that usually is implying something like g has a inverse. G has inverse. That's usually what they use that for. Sometimes they also use it, if g is strictly increasing, that means g prime is always positive. Let's see, and I believe that's all we could really say about g. The table above gives values of the function of the derivatives. The function h is given by, okay, so then they give us this arbitrary function here, h of x is equal to something. Notice that that's going to be a chain rule problem. So if they ask us for the derivative here, we would need a chain rule. Okay, so let's see what they're doing here. So I read the introductory paragraph, lots of information there. Let's go and see how this factors into the problem. So A. Oh, gosh. Explain why there must be a value r, for r being in between 1 and 3 exclusively, such that h of r equals -5. Okay, well, that's super confusing because I have no idea what they're talking about. But they do give me some stuff to work on, like this 1 and this 3. And they say that there's some r value in between 1 and 3, so that basically the x value in between 1 and 3, such that the y value is -5. And when I see something like that, I know that this is going to be a, let's do a fancy pen here. That means that's going to be an IVT. Okay. So how do I do that? Well, I need two endpoints to first bound it on. They told me in between 1 and 3. And again, I have no idea what the function looks like, but I just want to see what happens when I plot the 2 points, 1 and 3. I need a point, so here's -5, and I really need a point above and below at 1 and 3 to show that there's a y value. So let's see what we get. Let's go and do h of 1. h of 1 is f of g of 1 minus 6. Well, g of 1 is 2, so we need f of 2 minus 6. f of 2 is 9, so we have 3. So h of 1 is 3. Okay, I'm going to erase this to make room for the next part. Now let's go and do, and again, if I went too fast there, please feel free to pause the video and copy down what you need. Now let's do h of 3. And I did this in the wrong color, so I'll just change this here so now we know. Okay, h of 3 is equal f of g of 3 minus 6. Okay, g of 3 is 4. So I need f of 4 minus 6, and f of 4 is -1. So I get -1 minus 6, which is -7. Oh, that's excellent. Because no matter what the function does in between 1 and 3, the only way that I can get to -7 from I think this was Oh shoot, that's why I should have written this down. The only way that I could have gotten, I think this was 3. The only way that I could have gotten from the blue 3 to the purple -7, going from left to right, is crossing -5. So the IVT is going to hold here. Alright, so now let's go and set up the IVT. And I'm going to type this out because my typing is a lot better than my writing, I think. Okay, so why must there be a value for r such that h of r equals -5? Okay, well, we want to state that IVT applies first before actually showing that IVT works here. So the conditions for IVT is the function is continuous. We can say since h of x is dependent on g, f and g, f of x and g of x, and since f and g are continuous, differentiable, since f and g are differentiable, then f and g are continuous, which makes h of x continuous on its domain. Okay, so that's first. We're just stating continuity exists here for h of x because IVT requires continuity. Remember, if there is a break here in between, well, then we may not be so sure that we cross through -5. But if the function is continuous and we have to get to -7 without lifting our pencil, we must have continuity. So continuity is really important to start off. So now we can keep going here. Next, because h of x is continuous because h of x is continuous and h of 1 is bigger than -5, which is smaller than h of 3. So this is a fancy way of saying that the y value of -5 is in between h of 1 and h of 3. Then there exists, then by the IVT, there exists an r value, where r is in between 1 and 3, such that h of r value is equal to -5. And again, these are always kind of tough ones to have to write out, but this blue part is the big one. Because h of x is continuous and the y value, two y values, are around the -5, then by the IVT, there must exist a r value, at least one r value, where one, in between the value of the x values of 1 and 3, such that that x value, when plugged into h, has to equal -5. And that is A. Yikes. Let's go to B. Hopefully it's a little bit simpler. Okay, so this one. Explain why there must be a value C where h prime of C equals -5. Now the big giveaway here is the derivative equals -5. This is an MVT question. So let's first start off with h prime of x, because we're going to need it. H prime of x is equal to f prime g of x, so derivative of the outside, times the derivative of the inside. The derivative of -6 is 0. Let's go ahead and plug in h. This was silly. I didn't actually need to do this. Let's back up here. So we're going to show that we actually have a -5 value. So that what I really need to do here is to do h of 3 minus h of 1 over 3 minus 1. Now the reason I needed that is because I want to show that the average rate of change, which is what I wrote down, is equal to the instantaneous rate of change. And the instantaneous rate of change is, let's see, the instantaneous rate of change is this. This is what they're saying it should be. If I can get a blue equal to -5, and the function is continuous and differentiable, then I'm good to go. And I'll jot that down here for a second. So MVT requires, in order to use it even, continuous on a closed interval, differentiable on an open interval. And if both of these are true, then AROC equals IROC for some C on that open interval. Okay, so let's go ahead and calculate h of 3 and h of 1, which we did in the last slide. H of 3 was negative 7. So h of 3 was negative 7 minus, I believe it was minus 3 over 2. Negative 7 minus 3 is negative 10. Negative 10 over 2 is negative 5. Okay, so our average rate of change is negative 5. That's great. So we're ready to write down our answer. I got these two values, by the way, from the last question, in case you were curious. So let's write out our answer for the million value theorem. Because h of x is differentiable, we don't need to explain it more because we did it earlier, because h of x is differentiable on the closed interval, open interval 1 to 3, and differentiable, and continuous on the closed interval 1 to 3. Then there exists some c value. Oh, that's good. Such that h prime of c is equal to h of 3 minus h of 1, all divided by 3 minus 1. Now, don't ever write that out on a test like this because that's horrible, but there you go. Because you have a differentiability and continuity, then there must exist a value. And by the way, there must exist a value such that the instantaneous rate of change is equal to the average rate of change by the mean value theorem. Always give credit to where it's due. Don't ever forget to include that part. And I'm just going to underline this part. This was the blue part. That was the green part that they asked for. I should add on the interval on 1 to 3. And actually, hold on, one more thing here. I also want to specify that this was equal to negative 5. Equals negative 5. Okay, now I can keep going. Okay, for C, let W be the function given by, find the value of W prime of 3. Okay, these are a little bit easier. I have to take the derivative of the integral, so I'm going to make a side note. When you have to take the derivative of an integral, like k to g of x, of f of t dt, and you want the derivative with respect to x of that integral, well, you get f of g of x times g prime of x. In other words, you are plugging in for t, g of x, but then also multiplying this times the derivative of g of x. And again, if you need more practice on this, this is the fundamental theorem of calculus. This is FTC part 2. So let's get w prime of x. W prime of x is equal to f of g of x, plugging in that upper limit of integration, times g prime of x. And now let's go and get w prime of 3. That's f of g of 3 times g prime of 3. I'm just going to plug in some values here. I should have a prime here because it's derivative. Oh no, I'm sorry, that's false. What I had was correct before. There should be no prime there. Okay? I was thinking something else. Alright, so now let's go and get our answer here. So g of 3 is 4. So I need f of 4 times g prime of 3. G prime of 3 is 2. Now I need f of 4. F of 4 is negative 1. Okay, negative 2. That was a little bit easier, relatively. Next. If g inverse is the inverse function, write an equation for the line tangent at x equals 2. Okay, at x equals 2. Well, x equals 2 is on the inverse. So on the inverse, x is 2. On the original, the y value is 2. So I need to look on the original function for g, so I'm only looking at this column, the y value of 2, and the y value of 2 is right here. And that has an x value of 1. So that x value of 1, that's my buddy point. And now I need to get the derivative. So the derivative of g inverse prime of x is always 1 over the derivative of that y value. I'm sorry, 1 over the derivative of that here. Let me write this differently. In my class, what I showed you guys is that in order to get the derivative of inverse, take the reciprocal of g prime of x. So what we want is we want 1 over g prime of 1. So g prime of 1 is equal to 5, which means that I need my derivative, so g inverse prime of 2 is equal to 1 over 5. And again, this is just a very fancy way of saying derivative inverse of inverse at y value, at y value of original, at y value of original is reciprocal of the original derivative. Okay, so now to get the equation of the tangent line, again a little tricky here. You want to use this point because we are talking about the derivative of the inverse. We also want this slope. And now that we know that, we're good to go. Your answer, y minus 1 equals 1/5 x minus 2. Thanks for watching, guys.